Hey there, y'all. Today we're going to look at 4.4 on using intercepts, where this lesson might be better appropriately titled Standard Form of Linear Functions. And so our objective in this section is to be able to identify and use intercepts in linear relationships. And these fall under the two standards of FIF 7 and FIF 4 that we've done before. Now let's first talk about what is a linear function. Remember that a linear function is a function whose graph forms a line that is not vertical. And so when we look at our graph to the right here, the blue line and the red line and the purple line would all be linear functions because they are not vertical lines. However, the green line, while it would be a linear equation, it is not a linear function, as we talked about those vertical lines in section 4.3. So each of the lines that are graphed to the right is a linear equation. They all have a domain and range. So let's talk about those for a second. For both the red and the purple, both of those are going to be represented with a domain of all real numbers. And this little R symbol means all real numbers. We've looked at that before. And the range of this is all real numbers, because that red line is going down to negative infinity to the left, up to positive infinity to the right, and then it's doing the same thing going up and right. So it's going up here to positive infinity, out to the right to positive infinity. We look at the purple line, it's going to do the same thing. The domain is all real numbers, and the range is all real numbers. So we have both of those there. But what about the blue and the green? And we talked about horizontal and vertical lines in section 3, but we didn't talk about their domain and range. Well, remember that this line would be the line y equals 4, because every point along this line has a y value of 4. And so its domain is all real numbers, because it goes from negative infinity to the left to positive infinity to the right. But the range has just one value. The range is only that y is equal to 4. Now, we look at the green. It's going to be kind of similar, except remember, vertical lines don't start with y, but they start with x. And so x is equal to what? X is equal to negative 2. And it would have a domain of just x equals negative 2. And a range, now this is going to go on forever up and down, it has a range of all real numbers. So again, pay attention to these different lines and the domains and ranges that they have involved. Okay? Now, the last thing over here to the left. If a function is linear, then it can be represented by a linear equation. And a linear equation can always be written in standard form. Now, when we looked in section 1 in interpreting functions, we talked about the 3 different forms of a linear function. And the first of those is the standard form. ax plus by is equal to c. Now, the a, the b, and the c all have to be real numbers, and the a and the b both cannot be 0. So one of them can be 0, but not both. Okay? And to be a linear equation, the following pieces must be true. Both the x and the y must have an exponent of 1. The x and the y cannot be multiplied together, and the x and the y cannot appear in a denominator, in an exponent, or under a radical. All of those things must be true to be a linear equation. Okay? So we're going to look at some examples of how we deal with these and deal with graphs in standard form. So the first thing we want to realize is that any line that we have drawn on the coordinate plane has an x-intercept and a y-intercept. Now, horizontal and vertical lines are the exception. They'll only have one or the other. But any other line that is diagonal across the coordinate plane will have both an x-intercept and a y-intercept. And remember, the key is this, that the y-intercept, we'll start with that first. The y-intercept is the y-coordinate of the point where the graph crosses the the y-axis. And the x-coordinate of that is always 0. And so if we're looking at this picture here, this is the point at which it crosses the y-axis. And its ordered pair is 0, 6. Now, when we talk about the x-intercept, we're looking at the point at where it crosses the x-axis. And the y-coordinate of that will always be 0. And so if we're looking at this point here, its ordered pair is negative 2, 0. X-intercepts always have a y value of 0. Y-intercepts always have an x value of 0. the coordinate that we want is going to be the non-zero number. Now again, if we have a line that goes through the origin, then both the x and y-intercept would both be 0 in that case. But otherwise, we're going to have different values. And they are two separate points on the graph. Do not confuse this and write one order pair. 0, 6, negative 2, 0. Those are two separate points. All right, so let's see what's up next. So in example 1a here, we just want to find the intercepts of this graphed function. Now, pretty straightforward, right? We can look at the graph and say, hey, it has an x-intercept, it has a y-intercept. And so what is the y-intercept first? Well, that's where it crosses the y-axis. And that point is at what? Well, it's at 0, 3. Remember that the y-coordinate is going to be the y-intercept. We come down here. The x-intercept crossing the x-axis is at 9, 0, because our x is 9, and we didn't go anywhere in y, so it's 9, 0. Okay? That's it for example A. Let's look at example B. We've got a line here, 4x minus 10y is equal to 20. We've got to find those intercepts from the equation. But we know everything we need, because we said before that if I'm looking for the y-intercept, the x has to be what? 0. And if I'm looking for the x-intercept, the y has to be what? 0. And so we're going to have to do this 2 times. We're going to do it once to find the x-intercept, and then we're going to repeat the process to find the y-intercept. And so for the x-intercept, remember we said the y is 0. So I'm going to get 4x minus 10 times what? 0 is equal to 20. Again, when I'm looking for the x-intercept, the y is 0. I'm looking for x. And so this becomes 0. So I'm going to get that 4x is equal to 20. And if 4x is equal to 20, we divide both sides by 4, and we're going to get that x is equal to 5. Meaning that my x-intercept is at 5, 0. And for the y-intercept, we'll repeat the process. Except, instead of putting the 0 in for y, now I'm going to put the 0 in for what? The x. And so I'm going to get 4 times 0 minus 10 times y is equal to 20. This is 0, so I'm going to be left with negative 10y being equal to 20. I can divide both sides by that negative 10. And so y is equal to negative 2, meaning that my y-intercept is at 0, negative 2. Again, two separate ordered pairs. Make sure they are two separate ordered pairs when you write this. Do not write one ordered pair to this answer. Two separate ordered pairs. I hope you got me. Two separate ordered pairs. Okay, so let's look at the next example. So in example 2 here, we're going to look at a problem that's given here. We're going to figure out what intercepts it has and what those intercepts mean. So the temperature in an experiment is reduced at a constant rate over a period of time until the temperature reaches 0 degrees Celsius. The equation y equals 30 minus 1/2 x gives the temperature y in degrees Celsius x hours after the beginning of the experiment. Graph this function and find the x and y intercepts. Now, we don't always have to be given an equation in standard form to find the intercepts. We can still do our process and find the x-intercept and the y-intercept no matter what equation we're given. And so for the x-intercept, remember we're going to plug in 0 for y and solve for x. So 0 for y equals 30 minus 1/2 x. And so I'm going to subtract the 30 from both sides. So I get negative 30 is equal to negative 1/2 x. And then from there, we're going to need to get rid of the negative 1/2 x. And so I'm going to multiply both sides by the reciprocal. So I'm multiplying both sides by negative 2. And so I get that this is at 60 is equal to x. And so that gives us the order pair 60, 0. Now we do the same for the y. And so we're going to see that not 0, but y is equal to 30 minus 1/2 times 0. So y is equal to 30 minus 0, so y is just 30, meaning my y-intercept is at 0, 30. And so when we graph this, my x-intercept of 60, 0 is not going to fit on this graph. I only go out to 20 hours, so it's going to be way out there, right? But I do have the y-intercept here at 0, 30. Now, if I was to take this graph all the way out, we would see that it would look something like this. Get that line a little closer to where it's going to be. It's going to come out like so, continuing on down. Okay, so what do these intercepts mean to this problem? That's question B. What does each intercept represent? Well, the x in the problem was what? It's the number of hours. So y being 0 means I'm going to have 0 degrees Celsius, because that's the y. At what point? At 60 hours. So the x-intercept means the temperature reaches 0 degrees Celsius after 60 hours. The y-intercept, well, we got that it was 0, 30. Well, that means I'm at 0 hours and 30 degrees Celsius. And so we're dealing with the experiment, right? And so the temperature starts at 30 degrees Celsius. That's what those two intercepts mean. Okay? So that's where we're at in this problem. Let's go ahead and look at example 3 and look at how we're going to graph using intercepts. So like in example 2, we want to be able to solve this out and find our two intercepts, and then we're going to plot those 2 points and graph it on the coordinate plane. Okay? So in example A here, negative 2x plus 5y is equal to negative 10. And so we're going to set up our table. We're going to have our x-intercept. We're going to get our y-intercept. And so for our x-intercept, remember that's where we're going to get x, 0, the y-intercept 0, y. And so remember, plug into the appropriate spaces. And so negative 2x plus 5 times 0 is equal to negative 10. And so simplifying that, this will cancel. I get negative 2x is equal to negative 10. Dividing both sides by negative 2, we get that x is equal to 5, meaning that my x-intercept is at 5, 0. And that point would be there at 5, 0. Now let's do the work for the y-intercept. So negative 2 times 0 plus 5y is equal to negative 10. That cancels, so I'm left with 5y equaling negative 10. Dividing both sides by the 5, we get that y is equal to negative 2, meaning that my intercept is at 0, negative 2. Now, we plot that point. 0, negative 2 is here. And so we can take those 2 points, take a straight edge, and draw our line. And so taking this across, our line will come through like so. Okay? So again, we want to make sure that our line is straight. Again, we want to use a straight edge because this is a little off. It should cross here at 10, 2 at the end, but it is a little off just from not using a straight edge. Okay, so let's go ahead and look at example B. We see that this one is not written in standard form. Y is equal to 2/3 x minus 6. We can still graph it using our two intercepts. And so we're going to do what we've done before. Set up our table, x-intercept, y-intercept. Remember that the x-intercept is at x, 0. The y-intercept is at 0, y. And so we're going to do it for this function. So 0 is equal to 2/3 x minus 6. This one's going to take a little bit of work to solve it, so we're going to add the 6 first. And so we get that 6 is equal to 2/3 x. And then we're going to multiply both sides by the reciprocal. And remember, the reciprocal is the flip of the fraction. And so that's going to be 3/2. This cancels this. And so x is equal to what? 3 times 6 is 18. divided by 2 is 9. So x is equal to 9, meaning my x-intercept is at 9, 0. So that point is there. When we do it for the y-intercept, so we're going to have y is equal to 2/3 times 0 minus 6. This one's going to be very quick because the 2/3 times 0 is 0. So y is equal to -6. And so our intercept is at 0, -6, meaning my point is there. And again, we will use a straight edge to draw our line coming through those 2 points. That's it. Again, if we're asked to graph, find your 2 intercepts, plot those 2 points, draw the line between them. Use a straight edge to get your line straight. That's it. Last one in example C here real quick. A function has an x-intercept of 6 and a y-intercept of -3. We want to name 2 other points on this line. This is why it's important to not only get a nice line, but make sure it's nice and straight so we can tell what other points are on it. Well, they tell us the x-intercept is 6, so the x-intercept of 6 will be here. The y-intercept being -3 means it is here. And so if I take a straight edge and I draw across this graph, we see this line form here. And so we're looking for 2 other points that I can easily tell where they are at. And so when we look, I can see, oh, look, it goes through this corner right here. Well, that point is at 4, -1. I can also see that it goes through this corner. And that point is at 2, -2. And if we wanted more, we could talk about this one here at -2, -4. So we can list multiple points off this line. We can list points that are decimals or fractions. It's just how complex do you want to get in determining 2 points that happen to be along this function. That's it for this lesson. I hope y'all get it done. I hope y'all take your notes. Make sure you fill out the Google form, and I'll catch y'all next time.